Good afternoon. Good afternoon. Okay, so we'll just start, okay, directly. We'll not wait for the others to join. So this is the question paper. So start from the first one. A point charge q is placed at a distance a by 2 directly above the center of a square of side A. The electric flux through the square is. So there is a square, right, and suppose it's sitting on a surface. Okay, there's a square sitting on a surface like this, and the side of the square is A, right. Now they are saying that there is a charge that is sitting above this square, and the distance of the charge from the square is A by 2. Okay, so they are asking what will be the flux, electric flux. Electric flux is written with phi s or phi e, right, whatever you choose, phi e. Let us write phi e. Electric flux is written with phi e, and the formula for that comes from Gauss's law, which is q by epsilon naught, right. This is the formula. Now since what they are asking us, they are asking us what is the electric flux through the square. This is the square, right. So now this formula will be applicable when you have a closed volume, when you have a closed region, right. This is not a closed region, it's an open surface, right. So what you have to do, you have to consider 6 surfaces like this. Yes, so you can consider one surface here, right, another surface here, another surface here, right. So now you can see there are 6 surfaces. Now this is 1 2 3, the back one is 1 5 4, this is 5, and the bottom is 6, right. This is clear to you. So we have enclosed this charge inside a cube whose sides are A. Okay, that's what we have done, because in order to apply this Gauss's law we need a closed surface, right. We need a closed surface, so that's why we have done this. Is this clear? So is this clear, yes or no? Good afternoon. Is this clear? right? So we have enclosed it inside a cube whose side is A, right? And they're asking us to find the electric flux only through this red square here, only through this red square. So how many surfaces are there? There are 6 of them, right? So this the formula that I have written here is the flux through the whole box, right? This is the flux through the whole cube, right? So through only one of the squares, what will it be? You divide it by 6, you divide it by 6, so answer will be 1/6 of q by epsilon naught. Okay, this formula, this is comes from Gauss's law, this comes from Gauss's law, which we have done, right? Comes from Gauss's law and is applicable to a closed surface. If I have a closed surface and there is a charge q inside this surface, then the flux that comes out of the surface will be given by this formula, phi e is equal to q by epsilon naught. Okay, so now here also initially we had only one square and a charge which is at a distance of a by 2, right? So what we did, we enclosed this charge inside a cube, we created this cube, right? Because we want to apply this law, otherwise we cannot, right? So we created this and later we have divided by 6 because we want to find the flux only through one of the surfaces. There are 6 surfaces, so we want to find it only through one of them, right? So I hope that is clear to you. Is still not clear? Good afternoon. Is it still not clear or yes, answer number 1 is clear to you, yes or no? Good afternoon. Good afternoon. Just tell me quickly whether you have understood or not so that we can move ahead. If you don't reply, I'll assume that you have understood and move on. How do we know it? See, they have written here the electric flux through the square. Which square? The square that they have talked about here, right? So see, they are asking us to find the electric flux through the square, right? Which square is this? This is the square that they have told us. Okay, so that's why we know it's only through one surface. Understand? Because the other surface we are the one who have created, right? It's not there, so they cannot ask for the other surfaces. If it was for the whole surface, then they would have mentioned that. Okay, okay, repeat again. Okay, first of all, I hope you all know what is electric flux, right? If you have a charge q plus q, let us say you have a charge plus q, then this charge plus q generates electric lines of force, right? Just like we have magnetic lines of force, we have electric lines of force that start from plus q and they go towards a negative charge, right? If there is a negative charge near this, then it will go towards a negative charge. It will go in all directions equally, right? Like that. Understand? So these are your electric field lines that always start from a positive charge and go to a negative charge. Okay, so these are called your electric field lines, and the number of field lines that pass through a area, through a surface, is called electric flux. Is called electric flux. Try to relate it with magnetic flux, which we have done, right? So this is electric flux. Okay, so the question they're asking is, if I have a charge here plus q, so what will be the electric flux that passes through this area of the square? So right, so for that we have to know Gauss's law. This is Gauss's law, which says that electric flux, if I have a charge inside a closed surface, if I have a charge plus q, then the total electric flux that comes out of this surface is given by q by epsilon naught, right? So that is Gauss's law. But here there is no closed surface, so what we did, we created the closed surface by making other such squares and forming a cube, right? Forming a cube. So now we can apply Gauss's law here also, and it is the same formula. It is this formula only that will be used here also. But the thing is, we want to find only the electric flux only through this square, this area, right? We want to find only through this region, okay, because that's what they are asking in the question. So that's why what I did, I divided by 6, right? Because the electric flux will pass through all the regions equally, right? The lines of force that start from this charge will pass through all the regions equally, right? Equal amount of lines of force will pass through this like that, okay? So that way I have divided by 6 to get the flux only through one surface. Okay, now yes or no? Yes, is it clear now? Okay, so next question. Two similar charge spheres having plus q and minus q charges are kept at a certain distance. Force F acts between the two. If at the middle of the two spheres another similar sphere having charge plus q is kept, then it experiences a force in magnitude and direction as, so what will be the force? What will be the force and magnitude? So let me just draw the diagram for this. So they are saying we have two spheres. So this is one sphere here, and we have another sphere here, right? So this has a charge plus q and this has a charge minus q, right? And the distance between these two is given, okay, certain distance, right? So they have said that the distance between these two is some distance, let us say it is x, okay? Now they are asking, if at the middle of these two spheres, middle means somewhere here, we keep a third charge, whose value is plus q. Again there is a third charge here and the value of that charge is plus q, right? Question asked is what then what will be the force that it experiences, what will be the force that this one experiences, and what will be the direction of the force. So let us start with this one. So this is plus q, these are plus q. What will happen to them? They will repel each other, right? They will repel each other. So they will repel each other. So the direction of force will be this. This will be the direction of the force, right? And let us say that the force between these two is, how do you write the force between these two? You use Coulomb's law. Coulomb's law, which is F is equal to 1 by 4 pi epsilon naught, then multiply the two charges, q into q square divided by the distance square. What is the distance between these two? So I said the total distance from here to here is x, so the half of the distance will be x by 2, so this will be x by 2 whole thing square, right? This is the force between these two charges, right? And this is the direction. Now force between this charge minus q and plus q, what will be the force between these two? Again see, this is plus and this is minus, so what will there be? There will be attraction, right? Two like charges repel, unlike charges attract, so there will be attraction. So this plus q will go in the direction of minus q, so the force will be again in the same direction, right? let me draw here, right. So this red arrow shows the force because of these two, and the black arrow is for the force between minus q and plus q, right. So the direction is same for both. Now let us see what is the value of the force between these two. So again, F is equal to minus 1 by 4 epsilon naught, right. Now okay, so again now we will multiply the charges. What are the charges? Plus q and minus q. But remember, in Coulomb's law we don't take the minus sign. It is the magnitude of the two charges. We take the value of the two charges, we don't take the signs. So it will again be q square. Now what is the distance between them? Again it is x by 2 whole thing square. Did you understand until here? Until here, is it clear or there is any doubt? Yes, is it clear so far? X by 2, x by 2. Why x by 2? Because I have taken the distance from this point to this point, I have taken the distance as x, right. I have written here also, and they are saying that this plus q, that this third charge is in the middle, right. You can see here it's in the middle, right. So this is in the middle, so that's why this distance from plus q to this will be x by 2, half of this. Similarly here also half of this. Is it clear now? Okay, so right, okay, so again so the force between this plus q and this plus q is this one, right, and between this plus q and minus q is this one, right. It's equal. You can see there is no minus or plus sign because in Coulomb's law we don't take the minus sign, right. So they are the same force, yes or no? Okay, so what will happen? See, and look at the direction, they have the same direction. I have explained why the direction is same, because this two charges, they repel each other, so there is repulsion, so the direction will be this, right. They will push each other, so this will be the direction shown with the red arrow, and the force between these two, minus q and plus q, will be attraction. So the plus between, so the direction of the force will be again towards the black arrow, right. So they have the same direction. So what do? We add them, right. To find the total force we have to add them. So if I add them, look, if I add them, what will I get? I'll get 1 by 4 pi epsilon naught, right. This is common between these two, right. Between, okay, let me call this f1, let me call this f2. Between f1 and f2 they are common, this is common, so I am taking it outside the bracket. So what will I have to add inside? Q square. So x by 2 whole thing square, what is that? X square by 4. Same way here, q square x square by 4, right. Now 4 can come up, this 4 also can come up, so you can see this is x square by q square by x square, this is also q square by x square. So 4 times q square by x square plus 4 times q square by x square, which will give me 8. So 8 times 1 by 4 pi epsilon naught q square by x square. Is this clear how I got 8 times this? Okay, so that is the force between these two, right? Okay, now look at this. What is this inside the bracket? Look at the term inside the bracket. This term inside the bracket is the force between these two, between this charge, it's the force between this charge. Okay, let me just, okay, so the this term in the bracket is the force between this charge and the force between this charge, right? And what is that? That is F. It's given in the question. The force between plus q and minus q is F. So instead of this I can write 8F, right? Okay, so answer will be 8F and towards negative charge, right? Because you can see, look at both the arrows, they are going towards the negative minus q. So that's the answer. Is it clear? Okay, any doubts? Okay, I hope all of you have a question paper in your hand. So I'll delete this question paper from here, okay, because it becomes very difficult to write anything. Okay, so that's question number 2. Now let us look at question number 3. According to Bohr's postulate, which of the following quantities take discrete values? So if you have studied Bohr's postulate, I think it is the second postulate, which says the angular momentum question number 3, angular momentum of electrons in stationary orbits are quantized, right? If you have studied Bohr's law from atomic physics, you will come across this law, right? So angular momentum is quantized. What is the meaning of this? That means, okay, angular momentum is written with capital L, and it will take fixed values. It cannot take any value, right? It will take fixed value, and these values are given by nh by 2 pi. Okay, these are the values of angular momentum it can take if it's the first orbit. So right, let me draw the diagram. So in the center there is a nucleus, surrounding the nucleus there are electrons, right? So this is the first orbit of the electron, then you have second orbits and so on, right? So what is the value of n for the first one? It is n equal to 1, this is n equal to 2, right? So the angular momentum of any electron, here, right, any electron here will be this, any electron here will be this, but instead of n you will put 2, right? For to find the angular momentum of the electron in the first orbit, you put n equal to 1. To find the angular momentum of the electron in the second orbit, you put n equal to 2, right? You cannot just put 1.5, 1.1, whatever you feel like. Okay, so this is what the meaning of the question, which says that which of the following values take discrete value. Discrete means not continuous. The meaning of discrete is not continuous, so it is only angular momentum. Angular momentum has to take fixed values, it cannot take any value, right? Is it clear? Yes or no? Is it clear? Angular momentum part is clear. So answer for number 3 is C. Okay, you can take it in your question paper. Answer 3 is C. Question number 4. Now what is question number 4? The work function of a photoelectric material is 3.3 electron volt. The threshold frequency will be work function. What is work function? Okay, what is work function? First of all, okay, so I have to explain this. So suppose you have a metal, okay, this is a metal piece, and metal piece has electrons, right, free electrons. This metal piece has lots of free electrons. Okay, so there are lots of free electrons here. Now what happens if I allow light, if I allow light to fall on this, then, and if the light has sufficient energy, if the light has sufficient energy, then the electrons that are freely roaming in this metal can come out, right? If the light has sufficient energy, then the electrons that are freely roaming in this metal can come out. Metal has lots of free electrons, right? Those are called free electrons. So the metal has lots of free electrons. So what happens when light falls on this, and if the light has sufficient energy, then the electrons will come out, and this is called photoelectric effect. This phenomena is called photoelectric effect, right? So but the condition is that the light that falls should have a minimum amount of energy, right? If it's lower than that value, then the electrons will not come out, and if it's higher, then it will come out. That minimum value is called work function. That minimum value of the energy required is called work function of the metal, right? Understand? And it is denoted with phi 0, and the formula is h nu naught. Okay, the formula for the work function is h nu naught. H is Planck's constant, which you already know. Nu naught is the minimum frequency that the light should possess, right? Okay, so I think in chemistry last year you must have studied that light travels in the form of photons, right? Light can travel in the form of photons, and each photon has an energy h nu, right? So same thing here. The photon that falls on this metal plate should have at least this amount of energy, right? This is called work function. H is Planck's constant. Mu naught is called the threshold frequency. It's called the threshold frequency. Okay, so far it's clear, yes or no? Is it clear so far? Okay, right. So the question they are asking us is work function is this much, threshold frequency. So simple question, we'll put the value of work function, which is 3.3 electron volt, and h is how much? 6.626 into 10 to the power minus 34 joules per second, and nu naught we have to find. So nu naught will be equal to 3.3 electron volt divided by 6.626 into 10 to the power minus 34 joules second, right? Now electron volt is a unit of energy, and 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. Okay, so we have to convert them to the same unit, so answer will be 3.3. so multiply it with this to get it in joules, right? And 6.626 into 10 to the power minus 34 joules second, right? So cancel joule and joule, and answer you will get after solving this. Okay, answer will be in per second or hertz. Is it clear? Is it clear, yes or no? Okay, so you can do that. Next question. Question number 5. So what is question number 5? Magnetic induction due to a infinitely long straight conductor placed in a medium of permeability mu is. So suppose you have a conductor can be anything, it can be a wire, right? So let us say you have a wire, then they are asking what will be the magnetic induction because of this wire. If this wire carries current, then it produces a magnetic field. So what will be the value of the magnetic field? So this is very simple, you should know the formula. It's mu naught I by 2 pi a, right? This is the formula for the magnetic induction because of a long straight wire. But the question is slightly different here, because they have asked us if it's placed in a medium of permeability mu, right? This is the answer, this will be the answer when it is when the conductor is placed in air or vacuum, right? If you place the conductor in air or vacuum, then this is the answer. But in the question, the conductor is in a medium whose permeability is mu. So answer will be B is equal to mu I by 2 pi a. So this is the answer. Okay, question number 5 or 6, I think. 5. Question number 5. Question number 5 is clear, yes or no? Okay, next question. The unit of Henry can also be written as Henry. So Henry is the unit of what? Electric, inductance, right? Henry is the unit of inductance. And the symbol for inductance is L. So if you remember Faraday's law, E is equal to minus L di dt. This is the formula, this is Faraday's law, right? So here E is EMF is what? Voltage, current, time, right? So from here we can find another unit for L. So what is EMF? E is the EMF, and which is actually voltage. So unit of voltage is volt, capital V. We don't know the unit of L, so let me just write unit L, right? Okay, now this is current. What is the unit of current? Ampere divided by time. What is the unit of time? Second. So let me carry everything to the one side. So what will I get? Volt by ampere second, right? So volt per ampere second, right? Is that option there? Yes, the first option itself, volt per ampere second. Is it clear? Okay, next question. In an AC circuit, the applied EMF is this one and it produces a current of this one. So what will be the phase difference between these two, right? So this is from the chapter of alternating current. So the applied voltage is this one, E is equal to sine omega t plus pi by 2, and because of this you get a current in the circuit which is given by sine omega t minus pi by 2. So they are asking what is the phase difference. Phase difference means the time after which one starts, right? So this one you can, if you want, you can show it with a graph, right? So suppose you draw a graph between t and E and I, right? So this graph is both for E and I versus t. So let us first do it for E. So if I put t equal to 0, this will become E naught sine, so this will become 0, so sine pi by 2, right. So if I put t equal to 0 here, omega t will become 0, so it will be E naught sine pi by 2. What is sine pi by 2? Plus 1. So answer will be E naught. So E naught is the maximum, that means somewhere here, right. So at t equal to 0, the value of E is E naught, right. So somewhere here, understand, that means it will start from here and it will come this way. Right, somewhere like this. Okay, so this is your E. What about I? What happens to I at t equal to 0? So if you put t equal to 0 here, what will you get? You get again omega t is 0, so answer will be I naught sine minus pi by 2. What is sine minus pi by 2? Sine of minus pi by 2 is minus 1. Okay, so it will be minus I naught. Minus I naught is again the maximum value of I naught, but in the negative direction. So here, so this will be minus I naught. So that means at t equal to 0, current starts from here. Okay, current starts from here, understand. So this type of a relationship is there between your EMF and current. Now look, what is the gap between these two? Gap is pi, 180 degree. They are out of phase by 180 degree. Okay, so the question they have asked is, what is the by how much does E lead, right? See, to reach this point of maximum, I has to travel how much? I has to go from here and then only reach this point, right? So now look, this is pi by 2 and this is pi. Okay, if you put this omega t, so if you plot the graph between omega t and E and I, then this point here is pi by 2, this point here is pi. So in order to reach maximum value, I has to travel pi, right? So the gap is of pi, understand. E has already reached, but I has to travel a distance of pi, angle of pi, you can say, right? So that's why E leads by pi, understand. So answer for that will be pi. Is it clear, yes or no? Which one is confusing? Which one is confusing? Question number 7. Question number this one, that means, yeah, okay. So again, so question is, if you have, suppose you have a supply, okay, you have a circuit like this and you have a alternating supply given by this equation, E is equal to E naught sine omega t plus pi by 2, and because of this you will get a current, right, and that current is this one. Okay, so they are asked, so now look at the equation, they will not flow together, understand, they will not flow together, there will be a gap between these two. Is it clear? It's like this, suppose there is one person here, another person here, and let us say we tie them with a rope, right, we tie them with a rope, right, we tie them with a rope. So as long as they are going in a straight line, they will move together, right. So if this one is here, this one will be here, but now suppose there is a corner, there is a turn, then what will happen? This person, the person which is ahead, will reach here, whereas this person will still be stuck here, right, because the rope is like that, understand. So that is what happens in case of this also, understand. The EMF will lead, you look at this, omega t plus pi by 2, whereas this is omega minus pi by 2, understand. So just looking at the angles also, you can tell that one of them leads, right. So this one is leading. So the question is, by how much? By how much is it leading? So if I draw a graph, so how do I draw a graph? You put the values of t, right. If I draw a graph between omega t and ei, so first you start by putting t equal to 0. So if I put t equal to 0, then this term will disappear, omega t will disappear, and what will be left? Sine pi by 2. So sine pi by 2 is 1. So E will be E naught. So E will be E naught, that means here, right? Understand? At t equal to 0, this is t equal to 0 here. So E is here. In this, so during the same time, where will be I? I will be here. Why? Because if I put t equal to 0, again this term will disappear, and I will get sine minus pi by 2, which is minus 1. So minus 1, if I put here, I'll get minus I naught, which is here. Understand? So you can see there is a gap of pi between these two. Understand? How do you know it's a pi? Because if I want, so at this point E has already reached maximum of E naught, whereas for I to reach maximum, it has to travel how much? Pi. Is it clear now? Is it clear or still confusing? Okay, so now next question is question number 8. Okay, so this one is directly from the formula. I will not explain this. If you look at the formula for the potential, right, this question number 8, they are saying if a point lies at a distance of x from the midpoint of a dipole, the electric potential at this point. So dipole and all, I hope if you have studied. Question number 8, right, dipole is a system of two equal and opposite charges, so plus q minus q, separated by a small distance, which we usually take 2a, right? So this is called a dipole. It is a system of two charges which are opposite to each other but equal in magnitude. Understand? So they are asking what will be the potential at a point at the midpoint. So let us say this is the midpoint, and I keep another charge here on top of this at a distance of x from the midpoint. What will be the potential at this point? I mean, on what will it depend? Will it depend on 1 by x square? Will it depend on 1 by x cube? Will it depend on 1 by x to the power 3 by 2? Will it depend on 1 by x? That is the question they are asking. Understand? So the answer is 1 by x square. You can straight away look from the formula which I have given you. Okay. In fact, at this point it will be 0. The potential at this point will be 0 in fact, but since they have not given that option, it's 1 by x square. Okay. Okay, so that's question number 8. Next question, all these are definitions. Definitions I will not do here because it's waste of time. Explain the principle of superposition. So superpositions, so what is the use of superposition? First of all, you should know that. So this is type 2 question number 1, right? So superposition. So suppose you have many charges, q1, q2, q3, q4, q5, q6, q7, right? So what is the help of superposition principle? Suppose you want to find, so the force on this q1, the force on q1 will not be only because of q7, will not be only because of q6, it will be because of the combination of all these, right? q1 will experience a force which will be the combination of all these charges. Is it clear? So that is the principle of superposition. Force on q1 will be 1 by 4 pi epsilon naught, q1, q2 by r distance of them, let us say r12 square, again 1 by 4 pi epsilon naught, q1, q3, r13 square, 1 by 4 pi epsilon naught, q1, q4, r14 whole thing square, and so on, right? So this is the principle of superposition. It tells you that a force on a single charge will be the vector sum, okay? In this case you have to look at the direction also. It's not like you'll just add. Understand? So let us say this is your F1, let us say that this force is F1, then the force on q1 will be f1 vector plus, let us say this is f2 f2, so f2 vector plus f3 vector and so on. Okay, you have to look at the directions also. It's not like you'll find one number here, add them and get the answer. And is it clear? If they are in opposite direction, you have to subtract also. If they are in the same direction, you have to add all that. Is it clear? This is the principle of superposition. QF and H. What is that QF and H? Question number F and H. Okay, so I hope this is clear to you. So question number F. What is question number F? How will you define RMS value of alternating current? We have already done this. RMS value, so question number F, right? RMS value of alternating current is that value of steady current which produces the same amount of heat when passed through the same conductor for the same time. Okay, so that is RMS value. RMS value of alternating current is that value which will produce an amount of heat that is equal to the amount of heat produced by a steady current when they are made to pass through the same conductor for the same time. So I hope you know this from class 10 days, that if you pass electric current through a wire or through any conductor, it gets heated up, right? It gets heated up, and that heat generated formula is I square RT, right? This is the formula for the heat that is produced in a conductor, right, whose resistance is R, and I is the current flowing and T is the time, right? So steady RMS value of AC is that value of AC which will produce the same amount of heat as a steady current. Steady current means DC current, okay, battery, the current from a battery, okay. So if this current that is produced by this battery produces the same amount of heat as produced by AC current when passed for the same time and through the same conductor, then that value of AC current is called RMS value. It stands for root mean square. RMS stands for root mean square value. Okay, now yes or no? Question number F is clear? Okay, so that is question number F. Question number H. If the radius of orbit of hydrogen atom is 0.53 angstrom, what is the radius of first orbit of lithium 3 plus ion? Okay, so again, what does an atom look like? There is a nucleus in the center and surrounding it are are orbits where electrons move, right? So these are called orbits. Now for hydrogen, it has only one electron, right? Hydrogen has only one electron, one proton, so it has only one orbit, right? Lithium on the other hand, so this is the nucleus of lithium, let us say, and okay. So lithium on the other hand has two orbits because it has 3 electrons. Lithium has 3 electrons, right? So 2 on this one and 1 here, right? Okay, so they are saying that the radius of the first orbit of hydrogen, so this is your hydrogen and this is your lithium. So radius of this is 0.53 angstrom. Angstrom means 10 to the power minus 10 meters. Okay, so what will be the radius of the first orbit of lithium? Understand? Formula you should know is, the formula for this is n square into r naught by z. Okay, the radius of the lithium, this is the radius, right? Okay, so what is n square here? N square is the number of the orbit for which you want to find the radius. Suppose you want to find the radius for the first orbit, then you'll put n equal to 1. Suppose you want to find the radius for the second orbit, you'll put n equal to 2. Z is the atomic number, and r naught is this value, is the value of the first radius of the first orbit of hydrogen. Okay, 0.53, which is given. So we'll use this formula. So we want to find the radius for the first orbit, it's given in the question. So n, I'll put 1, so 1 square, r naught is 0.53 divided by z. Z is 3, right? Lithium, if you remember, hydrogen, helium, lithium, that is the third element in the periodic table. So atomic number is 3. So answer will be, you divide, so angstrom, so divide it, you'll get 0.1 to carry 7 and so on. Okay, 6, yeah, something like that. Okay, so this will be the answer. Is it clear? Yes or no? Is it clear? So that is question number H. Okay, rest of the question I think you can do, it's very simple. This numerical number E is also we have done many times, so I think you should be able to do. I'll not do that. Okay, short answer type using Gauss's law. Again, this derivation I have given in the copy, you can study from there and do it, nothing new. Obtain the expression for potential energy, this one also I have given. Obtain dipole moment also I have given. Obtain this one, right? So any question from here that you want me to do? Question number from 3, just have a look at 3 and tell me, is there any question you want me to do? FGH. A capacitor blocks DC but allows AC. Explain. So right, okay, we have done this. I have given a note also on this, but okay. So capacitor, what is a capacitor? So 3F, right? So capacitor, what is a capacitor? It's a device that can hold charge, right? It's a device that can hold charge. This is the symbol for capacitor. Right now, in the chapter of alternating current, we have shown that this capacitor can also offer resistance. That means it can also obstruct current, right? And that obstruction is called capacitive reactance, right? The obstruction that capacitor produces towards a current is called capacitive reactance, and the formula for that is it's written with xc, it's written with xc, and the formula is 1 by omega c. This is the formula for the resistance that is offered by a capacitor to current that flows through it, right? It's 1 by omega c. What is omega? Omega is the frequency of the current, right? Alternating current is given by, this is the expression for alternating current, right? So this omega is this one, okay? It's the frequency of the alternating current. Now C is the capacity of the capacitor. How much charge can it hold? So that is your C. Is it clear? Now look, so for alternating current, this omega has a value, right? Omega will have some value for alternating current. This is alternating current. This omega will have some value, right? And you will get some value here also, right? Let us say you get a value, whatever you want to pick. Let us say you get the value P, capital P, right? You will get some value. That means that if alternating current wants to go through this capacitor, it will experience some resistance because we get a finite number here. But let us say we have a steady current. What do you mean by steady current? A current whose magnitude remains same throughout, whose magnitude does not change, right? Whose magnitude does not change, it remains same throughout. In that case, there is no such thing as frequency for steady current or DC current. Steady current means DC current only, okay? The current that you get from battery, okay? It has a fixed value, it does not change, it does not go up, does not come down. So that's why there is no such thing as frequency, it's 0, right? So if you put 0 here for steady current, xc will be how much? Since frequency is 0, right? So if you put 0 here, what will you get? 1 by 0, which is infinity, right? So 1 by 0 means infinity, not a very large number, right? So that's why capacitor does not allow steady current to pass through it, right? It blocks it, understand? Because it offers a very large resistance, so it blocks it. Whereas for AC current also there is some blockage, but it's not very large, okay? Because we can find that value. Is it clear or no? Question number F is clear or no? Okay, so that is question number F. Then question number G, calculate the shortest wavelength of Lyman series. So number 3G, right? So Lyman series, first of all you should know. So suppose you have a nucleus at the center again, and you have other orbits here, like this, right? These are the other orbits where electrons move, okay? So what happens if an electron is moving in the first orbit, right? Suppose it is moving around in a first orbit and somebody gives it energy, then what will happen? If the energy gap between these two match, right? So see, look, this is your first orbit, n equal to 1, this is your second orbit, n equal to 2. They have different amount of energy. Anybody who is in orbit 2 will have a higher energy, anybody who is in orbit 1 has lower energy, understand? So if somebody comes from outside and supplies energy to this electron such that that energy is equal to this gap, right? There is a gap between this energy, and this energy supplied by that person from outside is equal, then what will happen? This electron will jump, this electron will go to the higher orbit, right? It will go to 2 in this case. And similarly, if that energy is equal to the energy to reach 3, then it can reach 3 also. that way. Is it clear? Understand? So this part is clear or not, right? So what happens after reaching 2? This electron does not stay in this orbit for too long. Okay, it will not, it's not like that it will go here and settle there. It will come down, it will come down after some time. Okay, and when it comes down, it releases energy. When it comes down, it releases energy, and releases energy in the form of light. What is the energy of light? H nu, right? From chemistry, if you have learned, light possesses an energy H nu. Is it clear? Yes or no? So this part is clear, only then we can go ahead. If it's clear, only then I can continue ahead. Just tell me. Right, so that is the energy that the electron will release when it comes back to its original level, right? Understand? And what happens? It releases light. Okay, and if you, and the group of those lights are called spectral lines, are called spectral lines or series, spectral series. Okay, spectral series. So the so it can go to 2, come back. It can even go to this 4, come back to 3, come back to 2, like that. Okay, it can take any path. It can come from 4 directly to 1 also. It can come to 4, from 4 to 3, 3 to 2, 2 to 1, like that. Okay, so electron can jump back to 1 from 2, it can jump back to 1 from 3, it can jump back from 4, jump from 5, right? So whatever lines that you collect, right, whenever the electron jumps to n equal to 1 from any other level, that lines that you collect are called Lyman series, are called Lyman series. Is it clear this point? Yes or no? Is that clear? Is it clear? Yes or no? Okay, so that is your Lyman series. Now they are asking question, the question they are asking is, what will be the minimum wavelength of the light? Okay, now look, this is the energy of the light that comes out, right? If it jumps from 4, again this will be the energy, but in this case it will be a little bit higher. Okay, let us say E1 is the energy when it jumps from 2 to 1. Let us say E2 is the energy. Okay, let us say E2 is the energy when it jumps from 2 to 1, E3 is the energy when it jumps from 3 to 1, E4 is the energy when it jumps from 4 to 1. Okay, so let us say these are the different amount of energy that the electron will release when it jumps from different levels. Now since the gap between 1 and 4 is more, so energy will also be more. So this will be mu 4, mu 2, right? Since the gap is more, energy will also be more. Is this part clear? Is this part clear? Excuse me. Is this part clear? Yes or no? Lyman series is the all such lines which you get when electron falls from 2 to 1, 3 to 1, 4 to 1, 5 to 1, 6 to 1, and so on. Okay, all the lights, all the frequency of light that you get when the electron jumps from higher level to the level 1 is called Lyman series. Then you have next one is Lyman P fund, right? P fund, in P fund what happens? So this is from atomic physics. Okay, if you have studied atomic physics only, then you will understand something, otherwise everything will go above your head, right? So what happens if you so in atomic physics, if you have studied these series lines, So first is the Lyman series, where it is a collection of lines you get when electron jumps from higher level to level 1. Then you have the P-Fun series, which is the collection of lines you get when electron jumps from higher level to level 2, Then there is Balmer, which is level 3. Then you have Pashkin, right, which is level 4, and then Bracket, which is level 5. Understand now? So these are your series lines. Okay. So now the question that is, okay, so this is the formula for the energy. Energy is equal to h by nu. What is nu? Nu is the frequency. Frequency can also be written as c by lambda, right? All this is done in chemistry last year, right? So I hope you remember it from there, but if you don't, just take it, that frequency, this frequency of the light that comes out is given by c by lambda. What is c? C is the speed of light and lambda is the wavelength of the light. Okay, c is the speed of light and lambda is the wavelength of the light. Okay, understand? Now look, more energy, less wavelength, less energy, more wavelength. This part is clear? Okay, so now there are, look at the question, they are asking us shortest wavelength of Lyman series, shortest wavelength. So for shortest wavelength, the energy has to be maximum. If you want this value to be smallest, this has to be maximum, right, because of this relation. Now there is a formula for this to calculate the wavelength. The formula is R 1 by n1 square minus 1 by n2 square. So this is the formula, understand? Okay. Now if you want to apply it for Lyman, then your n1 will be 1, because this is where the electron will drop. If you want to apply this formula for Lyman series, your n1 will be, for Lyman series, n1 is 1. Why? Because this is where the electron should drop, it should drop to 1, right? So that's why 1 by r will be, no, sorry, 1 by lambda, 1 by lambda will be r. R is a constant called Rydberg constant, I will explain. And n2 can be any value. N2 will start from 2. N2 has to start from 2 and it goes on and on, right? Understand? Is this clear? Now look, since they are asking, now see, if it jumps from higher level, energy will be more, right? I have explained here. If it jumps from higher level, energy will be more. So when will you get maximum energy? When will you get maximum energy? When it jumps from the highest level. What is the highest level? We don't know. It can be anything. It can be infinity also, right? Maximum, so it has to jump from the maximum height to release maximum energy, and maximum energy means minimum wavelength, right? And what is the maximum height? It can be from infinity. So that's why instead of n2 we'll put infinity, and the value of r is 1.09 into 10 to the power 7 per meter. So this is the value of r. It's a constant, it's called Rydberg constant. All this has been given in the notes, you should have a look. 1 minus 1 by n square. What is n? 2, it's infinity, so square. So 1 by infinity square, what is it? It's 0, right? 1 divided by a very very big number is 0. So lambda will be equal to 1 by lambda will be equal to 1.09 into 10 to the power 7 per meter, or lambda will be equal to 1 divided by 1.09 into 10 to the power 7 meters. So this is your answer for the smallest wavelength. Is it clear? Yes or no? Is it clear? Yes or no? Okay, so you have if you did not understand, you have to study atomic physics. Okay, because in one question I cannot explain the whole of atomic physics. You have to study that and go through the videos that I had sent during that time. Okay, now next question is question number what? um, Calculate the de Broglie wavelength associated with an electron accelerated with a potential difference of v. So formula for this is, formula for the wavelength, so 3h, formula is lambda is equal to h by root over, I am not sure about this formula, I have to look. So the formula for this is h by 2 MeV. Okay, this is the formula for the wavelength of an electron which is made to pass through a potential difference of capital V, and in our case it's 100. Right, if you put the value of h is a constant 6.626, m is mass of the electron which is also constant, E is the charge of electron, again a constant. So if you put the values of h, m and E, you will get 12.27 nanometer and divided by root over V. So what is V in our case? It's 100. So 12.27 divided by root over 100, which is 10 nanometer. So answer will be 1.227 nanometer. Is it clear? Yes or no? Clear or not? Okay, so that is your question number H. Again, if you have not understood, you have to study about de Broglie wavelength a little bit. So next question somebody had asked was 4b, 5c and de. 4b, okay. 4, okay, 4 again 4, question number 1 is derivation, which I have given. Do it. Question number B, charges are kept on the four corners of a square 1.3, calculate the potential at the center. Okay, so 12, 24, 31, 17, 12. So you have four charges and there's a square here, and the corners of these squares are four charges. right? 4 charges which are -12 microcoulomb, -24, -17 and -31, right? These are the I think, okay, plus these are plus, so plus 31 plus 17, what will be the so the question is, so there are 4 charges at the corner, what will be the potential at the center of the square, right? And the side of the square is 1.3, so this is 1.3, okay, so this is 1.3. now we need to know this, okay? So if you want to find, let us say you have plus q here, if you want to find the potential between these two, you have to know this distance, right? How to find this distance? This distance will be half of the diagonal of the square. This distance from this point corner to the center will be half of diagonal of the square, right? And how to find the formula for diagonal? I hope you know, it's Pythagoras theorem. Pythagoras theorem, diagonal will be square of this side and plus square of this side, so 1.3 square plus 1.3 square, because it's a square, so all the sides are same. So 1.3 means 1.69, 1.69, right, plus 1.69. so if you add these two, 18, 13, 1, 3, 3.38 divided by 2, because we want to find only till here, so diagonal will be divided by 2. okay, this is a square here, sorry. So yeah, so it will be 3.38, so this is diagonal, d square, d will be equal to root over of 3.38. find this value. So it's 1.84, right? So and so this is d, I want to find half of d, so divided by 2, d by 2 will be 0.92 meters. Is it clear how I got this distance is clear or not? How I got this distance is clear or not? Yes, clear or not? Okay, so that is how I got a distance. Now to find the potential, what will you do? Very simple, add all of them, right? So 1 by 4, so potential formula, if you remember, it's potential between 2 points q1 and q2 will be 2 charges, I mean, it's 1 by 4 pi epsilon naught q1 q2 by r. If the distance between these two is r, then the formula is this, right? But here there is no modulus, remember, there is no modulus. If it's minus q, you will put minus, if it's plus q, you will put plus. So that's what we will do. So you have 1 by 4 pi epsilon naught So if you want to find the value, then you have to put this 1, okay, because if I put q, then I'll get answer, but in terms of q, since you want the potential at this point, you use 1, okay. So 1 by 4 pi epsilon naught, what is this charge? 31 micro means 10 to the power minus 6, right? And what is the other charge? 1. So 1 divided by distance. What is the distance? 0.92. Same way, the potential because of 17 will be 1 by 4 pi epsilon naught 17 into 10 to the power minus 6. Again the other one is 1, so divided by distance, again 0.92, because all the corners are at the same distance from the center. Now third one is plus 1 by 4 pi epsilon naught. What is the third charge? Let us say it's minus 24, so you will get minus 24 here into 10 to the power minus 6. What is the charge at the center? 1 divided by 0.92. Let me put in the bracket. Plus fourth one, 1 by 4 pi epsilon naught. What is the fourth charge? Minus 12 into 10 to the power minus 6, and it's 1 divided by 0.92. This part is clear or not? Is this part clear? This is the potential at center. Yes, is it clear? Yes or no? 12, it's plus. Okay, it's plus, yeah. Okay, so if it's plus also no problem. So just put plus here, and this will also be plus. Okay, so you can find the answer. I think I will not do this, it's very long, will take a lot of time. What is the next question you want to ask from 4? Any question from 4? I think others are simple. For F, what is F? An AC source. Find the condition when the current will be in phase with the voltage. So the question is, you have a circuit where there is a resistance, and you have an inductor, and you have a third thing which is your capacitor, right? You have these three things, and this is supplied with a AC voltage which is given by E is equal to E naught sine omega t, right? So definitely there will be a current here, and that current will have some value, right? But it will not be in phase. That means they will not travel together. They will not travel together. The EMF and the current will not travel together. But under one condition they can travel together. What is that condition they are asking? So that condition is the resistance by the inductor. The resistance by the inductor has to be equal to the resistance by the capacitor. Okay, resistance by the capacitor I have shown you above, it's written with XC. Similarly, resistance because of inductor will be XL, so they should be equal. Under this condition your current and voltage will travel together. Okay, under this condition your current and voltage will travel together. Okay, now formula for XC I have shown you on top, it's omega C. Formula for L will be XL will be omega L. Okay, now if you cross multiply you will get omega square 1 by LC. So omega will be equal to root of 1 by root over LC. So when the value of omega is equal to 1 by root over LC, in that case your current and voltage will travel together and they will be in phase. We say when they travel together we say that they are in phase. Okay, when they travel together we say that they are in phase. So this is the condition. Okay, and this condition is known as resonance. This condition is known as resonance. Is it clear? Yes or no? You have to study this. Okay, if you are asking me from where I got omega L 1 by omega C, then that means you have not gone through the chapter, right? Any other question from 4? It's taking too long. I don't want to keep you for long, so just tell me quickly which are the other questions. Okay, so that is 4. Now numericals, rest is numericals. I think, what about 5? Any question from 5 that you want me to do? Have a look at 5 and tell me. 5 D and E, 5 C D E. Okay, let's see 5 C. An AC voltage. Okay, AC voltage is given 310 sine. Okay, so there is an AC supply. So AC supply is given by E is equal to E naught sine omega t, and in the question they have given us values for these. So E naught, so they have given 311, I think 310 sine 314 t, right? So this is the voltage supply that you are using for a circuit which has a resistor, inductor and capacitor, just like the one we have drawn above, right? So this circuit has a resistor, it has a inductor and it also has a capacitor, right? And the supply voltage is this one that I have written here. Okay, so the resistance is 24 ohm, right? And what is the 0.1? 25, 0.1 Henry, and this is 25 microfarad. Okay, farad is the unit of capacitance. I have not done this capacitance chapter, but later on. Okay, just for now, just remember that F stands for farad, F-A-R-A-D. Okay, it is the unit of capacitance. Micro is same everywhere, 10 to the power minus 6. Okay, it's clear the question. So so they have asked us what? Calculate peak voltage, RMS voltage, frequency, reactance of the circuit, impedance of the circuit, and phase angle. So very simple. So first of all, peak value. Now peak value, look, this is called your peak value. Understand? Now compare these two. What will be your peak value? Peak value will be 310 volt. Okay, so that is your peak value. Now ERMS, the relationship between ERMS and E naught is E naught divided by root 2. Okay, so this is the relationship between peak value and RMS value. So if you put the value, you will get 310 divided by root 2, which is 1.414. So if you solve this, you will get ERMS. So far it's clear, yes or no? So far clear? Yes, is it clear so far? Yes or no? Okay, so I'll assume that you have understood. Now next thing they're asking is frequency how to find. Now see, look here, compare these two. Omega is 314, right? Omega is 314. This is called angular frequency. Okay, angular frequency. So I I don't think they have asked us this. There is two type of frequency. One is linear frequency f, one is angular frequency. So angular frequency directly you can see from here is 314, but in case they ask you f, then it will be the relationship between omega and f is 2 pi f, right? So you put that 2 pi f is equal to 314. So f will be equal to 314 divided by 2 pi. So 314 divided by 2 pi. What is the value of pi? 3.14, right? So if you cancel 3.14 with 314, you'll get 100 here. So answer will be 50 hertz. This is the frequency. Now next they are asking reactance. So there are three types of reactance. One is reactance because of resistor. So that is directly R, value is 24 ohms, right? The next one is the reactance because of inductor. So that is XL, formula is omega L. L is given, omega is given, put the value, you will get the answer. XC, that is the reactance because of capacitance, formula is 1 by omega C, put the value of omega. C is also given in the question, right? These 0.125 are the values of L and C respectively. Okay, this is your value of L, this is your value of R, this is your value of C. Okay, so you put them here, you will get the reactance, three of them. Okay, and last one is impedance. Impedance formula, impedance is the total resistance in the circuit. The formula is R square divided R square plus XL minus XC whole thing square. So if you get the values from here, put them here, you will get the answer. Okay, and last one is phase angle. Phase angle is phi, and the formula is tan phi is equal to XL minus XC divided by R. Again put the values, you will get the answers. Is it clear? Is it clear? Is this question is clear or not? Okay, it's just formula, nothing. If you know the formulas, you can do that question. Okay, then D and E. Okay, then this one, this is a question, transformer, right? If you remember transformer is a device like this, right? And you have wires here and you have wires here, right? You supply input from here, and according to your wish, you'll get an output here. If you want more, you'll have to use a step up transformer. If you want less, you have to use a step down transformer. So suppose supply is so this is called primary P, this is called secondary coil. So supply is EP, then current produced is IP. Suppose you get here ES secondary, and current that you get is IS, right? So according, so efficiency formula is eta is given by output power divided by input power. Okay, this formula I have given you, I have explained. Output power, so output power we don't know, but there is a formula for power is equal to E into I. This is the formula for power. So output power will be ES into IS, right? Now input power is given in the question. How much is it? It is connected to a power input at 4 kilowatt. So this is the input power. Okay, 4 kilowatt is the input power. Now efficiency they have said is how much? Efficiency is 80%. 80% means what? 80% means 80 divided by 100, right? Percent, if you want to change it into fraction, you divide by 100. So you'll get 4 by 5 here, 4 by 5. Now one more thing they have told us, that the output voltage they have given us. Look at the output voltage, it's how much? 240 volt, right? If the secondary voltage is 240, so instead of ES I can put 240. So 240. Now IS I have to find. So 4 kilo means what? 1000. So 4000 watt. Okay, so now if I solve this, I will get 4, this one will be 65, this one will cancel, you will get 800, So answer will be 80 by 6 ampere. Answer will be 1.3, no sorry, 13.3 ampere. This is the current that will flow in the secondary circuit. Is it clear, yes or no? I'm doing a little bit faster. If you're not understanding, just tell me. But okay, so that is the second part of the, that is the answer to the second question. Okay, there are two questions here. If you read, calculate the primary and secondary current. So secondary current is that one which we got just now. Primary current, we also have to find the value of IP. So how to find the value of IP? See, input power is given to us, right? Input power. So I told you above, formula for input power is E into I. So for input it will be EP into IP. So input power is given, how much is it? 4000 watt, 4 kilowatt, right? And one more thing they also have given is, in see this 100 volt, can you see this is the input voltage, 100 volt. So EP is 100 volt. Okay, so IP you can find. So IP will be equal to 4000 divided by 100. Cancel this, answer will be 40 amperes. Is it clear, yes or no? Okay, so that is now last question, I think 5E. Okay, this is the formula for torque. This is from first chapter, right? So what happens here, if you have electric field, suppose you have electric field E, suppose the electric field is E and you keep a dipole. I have explained what is a dipole, right? It's a system of two charges separated by a small distance. So this dipole will experience a torque. It will rotate in this electric field, right? Why? Because let us say this is plus Q, this is minus Q, right? Why? Because okay, you know electric field starts from plus and minus, right? So this one will be, okay, let's say this is minus. So this is plus and this is minus. Okay, what will happen? This minus will be pulled towards this side, so it will experience a force here. Let us call it F, and this will be pulled towards here, so this will again experience a force F, right? So you see this way it will rotate. This will be pulled up, this will be pulled down. Again that will rotate the dipole. Okay, and that rotation is because of torque. We call that turning effect is called torque. So they are asking us to find two questions. One, find the force. Other, find the torque. So how to find the force? Very simple. Force formula is take any charge you can take, because they are same, right? Value is same. Look at the question. Value is 2 into 10 to the power minus 10 and minus 2 into 10 to the power minus 10. So the number is same, even though the signs are different, number is same. So take any value. So the formula is Q times electric field. So Q is 2 into 10 to the power minus 10. Electric field that is given is how much? 10 again. So 10, so answer will be 2 into 10 to the power minus 9. So this is the force that either charge will experience. It will be same, okay, because the value is same and electric field is also same for both. Is it clear, yes or no, this question? Yes or no? Okay, so that is the force experienced by either charge. Now torque, what will be the torque? Torque formula you should know if you have studied, is P cross E. P cross E, right? Now cross means sine theta, so instead of cross you can put sine theta, right? What is P? P is a dipole moment. How do you find? Q into distance, right? This is the P. q into distance. E is given, it's 10. Angle is also given. Angle means this angle, okay? It's given in the question, 60 degree, right? So sine 60 degree. Now q is how much? 2 into 10 to the power minus 10. Distance is how much? 5 millimeter. 5 millimeter. So you have to convert to meters. So it will be divided by 1000. Okay. 10 and sine 60 degree is root 3 by 2. So 10 cancel. So 5 into 2 10. Again that will cancel one more from here. Now what will be left? This 10 will go up. It will become minus. So 10 to the power minus 11. So root 3 by 2 into 10 to the power minus 11. Torque formula is Newton meter. Okay, this is the formula. This is the answer. Okay, I hope numerical part you can do, but just understand the formula is P sine theta. P is the dipole moment, which is given by Q into the size of the dipole, and rest of the things is I've already explained. Yes, is it clear? Yes or no? Is it clear? Okay, so if I went too fast, please have a look at the video once again, and if you still don't understand, then you can ask me in the next class. I had to go fast because I have taken a lot of time. Okay, it's more than 1 hour 42 minutes. Okay, so the video will always be there. So if you did not understand anything, I suggest that you first study that portion. You study that portion and then go through these videos. Okay, the stream is public. Yes, I have put it in public, so you can have a look. Okay, so do that, and still if you don't understand anything, you can ask. Okay, then I'll see you.